All right, so today we are going to use FTC Part 2, which is a wonderful thing that tells us that the definite integral of f between a and b, the area under the, we can kind of think of it as the area under the curve, can be now simply evaluated by finding the antiderivative cap f and then plugging in b and then subtracting a, f of b minus f of a. So we're going to use it and just kind of get used to using it here. All right, so I have the definite integral of cosine of x from 0 to pi. So the first thing I need to do is find the antiderivative, which is the sine of x. And then this notation, so this integral and the dx say, okay, I need to find the antiderivative with respect to x. Once I've done that, now I put this line because I don't want to write this integral again because I've already done the antiderivative, but I need a place to say, okay, well, I still need to put these in, okay? So now this is equal to, now I'm doing this, right? The sine of pi minus the sine of 0. And both sine of pi and sine of 0 are 0, so this is actually equal to 0. Now you might be thinking, well, how is that possible? Okay, so I sketched a little graph of cosine of x from 0 to pi. And so here is cosine at 0 is 1, and cosine of pi is -1, and cosine of pi over 2 is 0. So I actually look like this. And these are two symmetric pieces where the positive part and the negative part are precisely equal to each other. So they just cancel each other out. Okay? So that's why we know it's the net change in area. Okay? So let's use it again. So this time we just have a polynomial function, a quadratic function that we want to find the antiderivative of and plug in our endpoints. So we have the definite integral from 0 to 2 of 3x squared plus 4x plus 1 dx. And I'm going to first find my antiderivative, which is then x cubed. It'll be 3x cubed over 3, so I'm not going to write that because the 3's cancel each other and get 1. And then I have plus 4x squared over 2 plus x, and I evaluate from 2 to 0. Now, one thing with the definite integral is we don't add the plus c, because technically here, when I evaluate the f of b, that would have a plus c, and then I subtract f of a, which also would have a plus c, and so when this one minus this one ends up just canceling out the c's, so we just don't write it, okay? So I have calculated the antiderivative. Maybe I'll simplify this one more time here. Actually, here, let me move up a little bit. So let me simplify this one more time because I can call this 2x squared and it'll just make my life a little easier when I'm plugging in numbers. So I have x cubed plus 2x squared plus x, and I'm going to plug in my 2 and my 0. Now be very careful, like this one up here was easy because I only had one term. When I subtract, make sure you use parentheses, okay? So I'm going to plug in 2 completely first, and that's going to give me 2 cubed is 8, plus 2 times 4, which is also 8, plus 2. So this is cap f of 2, right? The antiderivative evaluated there. And then I'm going to subtract. Now actually then when I plug in 0, these all turn to 0. And so I just get 8 plus 2, so that is 16 plus 2, which is 18. I chose my numbers carefully so we'd have nice integers. Okay, so that is evaluating those. Okay, so let's look at another example. So this time I have the absolute value of cosine. Okay, so we did talk briefly about absolute value, right? So when I don't have the absolute value bars on there, then I'm looking for the net change, and we've already evaluated cosine doing the net change, and we found out it was 0 because the area beneath the curve and the area above the curve essentially cancel each other out. But this time, when I use the absolute value bars, I'm really kind of looking for the total distance that cosine is actually traveling. Now, we've already kind of looked at this picture. If we don't know what this looks like, then we need to look up the graph or graph it, okay? Because what I need to do in order to do this, now I can kind of, maybe I can kind of tell, but essentially these two areas must be equal to each other, right? So what I need to do in this particular case, now I'm not going to know that in every case. I just know that because we went from cosine from 0 to pi, I got 0, that these two must be equal to each other. But what we want to do then is here we're going to break up cosine, and rather than the absolute value, we're going to, so that we can deal with it, we're going to break it up right here, where from positive, so we would do the integral of cosine from 0 to pi over 2 of cosine of x, because that's the positive one. And then what we do, because we know that when we do this next integral from pi over 2 to pi, I'm going to get a negative value, so we put a minus sign in front of it and subtract it. So we evaluate this in two different sections. Now I don't have to do the antiderivative again. I've already know what it is, right? So we already knew that this was sine of x, and now we're going to evaluate it like this, okay? So this is equal to 0, or actually from 0 to pi over 2, and this will be regular cosine of x dx, and then we're going to subtract, because this will be the negative part, from pi over 2 to pi. Now you can just calculate them separately and take the absolute value of the one and add it. That's perfectly fine as well. Okay, so I have this, but I already know that the antiderivative is sine. So in this particular, for this one, I'm going to evaluate it at pi over 2 and 0. And then over here, I'm going to evaluate it at pi and pi over 2. All right, so the sine of pi over 2, I'll write it out here. So sine of pi over 2 minus the sine of 0. And then over here, we have the sine of pi minus the sine of pi over 2. All right, so the sine of pi over 2 is 1. The sine of 0 is 0, so this becomes 1. And then over here, I get the sine of pi, which is 0. And then this is 1 as well, so I get 0 minus 1. Now remember, I'm subtracting here, so this one is equal to 1, and this one is equal to negative 1, right? So then when I subtract, or I think, okay, well, I'm going to turn this one positive, in the end, I'm going to get 2. So it just becomes 1 plus 1. Now, once I calculated this and I knew that they had to be equal, obviously I knew that this was also going to be 1, but just showing the process of it. Okay, so let's think of this next one as the velocity, right? So we'll call this v of t, and we'll say v of t is t squared minus t minus 12. And what we're going to get out of here is the net change in distance, right? Because when I do the antiderivative of v, I get the position function. And when I evaluate the position function, I'll end up with s of 5 minus s of 1 as because my antiderivative will be s. So that means it's going to give me the net change in distance between when t was 1 and t was 5. So let's go forth with our antiderivative. So this will be 1/3 t cubed minus 1/2 t squared minus 12t. And then we're going to evaluate it. Sometimes I use a bracket, sometimes I use a straight line. It means the same thing. It means I still need to evaluate it. Okay. So I'm going to start my calculations over here. I'm going to plug in 5 first. So 1/3 times 5 cubed is 125. And then I have minus 1/2, and t squared is 25. Then I have minus 12 times 5, which is 60. Right, and then I have minus my big parenthesis here. And now I'm just going to plug in 1. So that's going to give me 1/3 minus 1/2 minus 12. All right, so what I like to do then is I'm going to write these as improper fractions first. So this is 125 over 3 minus 25 over 2 minus 60. Yes, my dogs are running through the house. And then I am going to distribute my minus sign here. So this is going to be minus 1/3 plus 1/2 plus 12. All right, so I see that these are thirds, and this is 1/3, and this is 1/2, and this is 1/2. So I'm going to try to simplify it. Maybe I'll get integers if I do that. Unfortunately, I'm not going to on my first one, because 125 over 3 minus 1 over 3 is going to give me 124 over 3, which unfortunately isn't an integer. So I've dealt with those. Now I have negative 25 over 2, not the 125, just negative 25 over 2, and then plus a half. So that is going to give me negative 25 plus 1 is negative 24 over 2, which is just a minus 12. And so I've taken care of that. And then I have the minus 60, and then I have this plus 12 on the end that I haven't dealt with. Now these 12s end up canceling out, and I'm left with 124 over 3 minus 60. At this point, it's fine to just leave it like this, or if I really want to go crazy, I can do 124 over 3 minus 180 over 3. So I'm going to get, let's see, 180 minus 24 here is going to give me 6, and negative 36. Nope, that can't be right. Nope, definitely not. Okay, so actually 124. But anyway, it's going to be negative because 124 minus 180 is going to be negative something. So what that means is that if I look at this graph, that means that the more of it will be underneath than will be above, okay? So basically what that means, right, is that my position, well, when I'm dealing with velocity and when I move in a negative direction, that means I move to the left, okay? So if it's positive, we move to the right. So that means basically my object is moving to the left, whatever that is, because obviously I can't do the subtraction. That would actually be more like 5, right? 56. How about 56? Negative 56 over 3. I knew it didn't come out to be an integer. Okay. So what if I wanted to know the distance? So this was just the change in distance from where I started to where I finished. This means I finished essentially negative 56 over 3, whatever decimal approximation that is, to the left of where I started, okay? So what if I wanted the total distance that I traveled, okay? In this case, then, to get the total distance traveled, I take the absolute value of the velocity function. So we've already done the antiderivative already, right? So I'm just going to rewrite, well, actually, let's talk about what we need to do first. Okay, so first of all, if I'm going to do the absolute value of this, I really need to know where the graph is above and below the x-axis, because I know that, like, if I just calculated this like I just did, I get a negative displacement. But I want now the total distance traveled, so that means I need to figure out where my graph is, or where my area would be below the x-axis and where it's above the x-axis, and separate them. So I just did a quick sketch. So I just took this out here, and I wanted to know, I know it's a t squared, so that means it's going to be a parabola. I factored it really quick just to find the x-intercepts. I graphed them here. I know it's an upright parabola. So really, like, the displacement was, why it was negative is because this great big piece here is negative, and then here is 5 out here would be this part. So I only had this little tiny positive part here, and the rest of it was negative. But now we want to count this also as negative, or I mean as positive. So we need to separate it, because if I do it together, then I just get this minus this. But I really want this plus this, so I need to separate it. So the way that I do that, based upon this picture, right, is I'm going to break up my interval. So I know that the positive part is from 4 to 5. So I'm going to start with that. So this would be the antiderivative of, I'm going to remove the absolute value bars this time, from 4 to 5, because that I know is positive. So this is t squared minus t minus 12 dt. And then I know that this other piece from 1 to 4, actually, like, we only had this part here because it started at 1. So that was so we didn't actually count this part, but it's still bigger negative here. Okay, so I know that it's negative between 1 and 4. So that means I'm going to do that integral separately. And the way that I could write it, so I can do it 2 ways. I can write it from 1 to 4 of t squared minus t minus 12 dt. And I can either say minus this, because then I'll subtract the negative, or I can just calculate these separately take the absolute value of this and just add them together, whichever you prefer. Okay, so now we don't have to do the antiderivative again twice because we already know what the antiderivative is from this previous page here. So let's copy this down here. So this would be, I'm just going to write it once. So 1/3 t cubed minus 1/2 t squared minus 12t. Okay. So the first one that I'm going to do is the 5 to 4. Okay. So I'm only going to, I don't have to do this antiderivative again. I've already done it. Okay. So I just need to evaluate it differently. So first I'm going to do from 5 to 4. So that would be, I plug in the 5 and I'm going to get 125 over 3 minus 25 over 2 minus 60. We've already calculated that once, right? And then we're going to have minus, put my parentheses there. When I plug in 4, 4 cubed is 64 over 3. And then I get minus 16 over 2, and then minus 48. All right, so this is my first calculation, and this should be positive value. We'll come back to it. And then I'm also going to do the same thing. I'm going to evaluate from also 1 to 4. We always say the bottom one first. Okay, so again, so when I plug in the 4, I'm going to get, I've already plugged in the 4, so I get exactly the same thing again. I plug in 4 and I get 64 over 3 minus 16 over 2 minus 48. And then I'm going to subtract 1, and I'm going to get 1/3 minus 1/2 minus 12. Okay, so now which one should I do first? Okay, so up here, maybe I'm just not going to. So basically I'm going to just calculate this, right? I'm going to calculate this. It should be a negative value, right? And then I'm just going to add this and then plus the absolute value of this to it. And that's going to be my total distance. So you can just put that in your calculator. It's okay in these cases to decimal approximate it. Or really at this point, it's perfectly fine if you just kind of leave it like this. Maybe I would combine these fractions or whatever, but that's the process. You can finish it.